Section 3.4, the chain rule. The objectives for this section are: find the derivative of a composite function using the chain rule. We're going to use a general power rule for finding the derivative. We simplify the derivative using algebra, and then we try to find the derivative of trigonometric function whenever it's needed using chain rule. And we're going to also talk about different varieties of natural logarithmic function, derivative of natural logarithmic function, and eventually finding the derivative of exponential function with the base other than e. So these are our objective. So chain rule, we need chain rule whenever we have a function which is not simple looking. Sometimes the function could be very complicated looking. So we can make a chain and we can break that function into different function, and we can find the derivative of individual function to find the derivative of as a whole, the big function. I'm going to give you the rule first. Let's say you have a function y, which is a function of u. Remember, u is another function. U is a function of x. So here is the chain. First, y is a function of u and u is a function of x. There is a chain. And now we want to find out the derivative of y with respect to x. How can we do that? We can find the derivative of y with respect to x by using this formula, which is called chain rule. The chain rule. First, to find the derivative of y with respect to u and times it by derivative of u with respect to x. There is another way to, if we would like to write down the very same thing in different way, this is the equivalent way. I'm going to give you an example here. But before that, it would be easier for us to visualize if we, think of this. When applying the chain rule, it would be helpful if we think that function as a composition function. So like in this theorem here, y is a function of u, so we can write it down like y is a function of another composition of two different functions, f and g, where g is a function of u. You see, g of x is a u. So this is the inner function, u is the inner function, and f is the outer function. For finding the derivative of this kind of composition, we use the rule that's called the chain rule. So how do you find it? Find the derivative of y prime, which is derivative of f prime, which is the outer function with respect to u, times it with the inner function with respect to x. Okay, let's take one example here. Y is x squared plus 1 to the power cube. Here we can say this inner function as a u. U is x squared plus 1. So by doing this, we can write down y as a function of u. You see, what is u? U is a function of x. U is a function of x. So the chain rule says, for finding the derivative of y, find the derivative of f with respect to u. Don't forget that it's not with respect to x, it's with respect to u, and times it by the derivative of u with respect to x. You see, so we need to find these two values. What is the derivative of f with respect to u? So y is function of u. What is y? Y is u to the power q, because this inner function, we denote this as a u. So what is the derivative of f with respect to u? We can use the power rule, and that is 3 times u squared by using the power rule. So what is the derivative of u with respect to x? Look at here. This is the u function. What is the derivative of this function with respect to x? It's a 2x. So now eventually, if we want to find out the derivative of the original function with respect to x, we can just plug the value of these two derivative. So what is f prime of u? This is 3 times u squared. What is u prime of x? That is 2x. But remember, the original function is function of x. We're just changing it into different chain so that it would be helpful for us to find the derivative. But eventually our answer has to be in terms of x. So eventually this you need to change that in terms of x. So 3 times, what is u? U is x squared plus 1 whole square times 2x. So that is the derivative of the original function. Let me just summarize that thing here. So the derivative of y with respect to x is 3 times x squared plus 1 squared times 2x. That's what we found here. 3 times x squared plus 1 squared times 2x. And then if you multiply this 2x and 3, that gives you 6x. Okay, so we can use the chain rule for finding this general power rule. So let's say y is u to the power n. So what is y? Y is nth power of another function u. So for finding the derivative of y, we can just use the power rule for the u, which is n times u to the power n minus 1, and times it by du over dx. Remember, this is not x. This is function of x. That's why this formula here, this rule here is called general power rule. So what is the derivative of u to the power n, where u is the function of x? It's n times u to the power n minus 1 times derivative of u with respect to x. One example, we can treat this inner function as u. So f of x is u to the power cube. So what is the general power rule? The derivative of f with respect to x is 3 times u squared times derivative of u with respect to x. That's the general power rule. If we go back and here and then check, n times u to the power n minus 1 times du over dx. So in this case, n is 3. So 3 times u squared times du over dx. Eventually, we need to plug the value of u, which is in this case 3x minus 2x whole square and 2. Du over dx means finding the derivative of u, which is 3x minus 2x square. What is the derivative of u with respect to x? It's a derivative of the first term, which is 3, minus derivative of the second term, which is 2 times x. Eventually, it's a 3 minus 4x. So this is 3 minus 4x. So that's the derivative of the function f with respect to x. And that can be found by using the general power rule. So that's the, final answer here. Okay, so sometime or most of the time after finding the derivative, we need to simplify the derivative. For example, look at here. We have given the function f of x, which is x squared times the square root of 1 minus x squared. We can find the derivative of this function by using the product rule. Here, the first function is x squared and the second function is 1 minus x squared to the power half. Using the product rule, we find this expression. But eventually, after finding this expression, remember the product rule is if your f is, let's say, two different functions g and h, then the derivative of f is the derivative of the one function times the another function plus the derivative of another function times the next function. So in this case, z is x squared and h is 1 minus x squared to the power half. So this is the product rule. But after applying the product rule, we can further go and simplify the expression here, because eventually we don't want to just keep our answer as is, like whatever we found from the derivative. We need to do some cleanup. So that's called simplification. So that's what I did here. And then finally, my answer is this one. So always keep in mind, after finding the derivative, if it's possible, go further and simplify your answer. So transcendental function and then chain rule. Chain rule is could be useful while finding the derivative of the trigonometric function. For example, if your trigonometric function, let's say sine function is sine u, where u is the function of x, then in that case, the derivative of sine u is cosine u times du over dx. And same thing applies for rest of the trigonometric function. Even for the exponential function e to the power u, where u is function of x, then derivative of e to the power u is e to the power u times derivative of u with respect to x. So we can apply the very same idea to all the trigonometric function and an exponential function, the chain rule. Examples. Let's say y is sine 2x. You see here, it's not just x, it's 2x. So we can treat this 2x as a u. Now, using that formula we're talking here, the derivative of y is the cosine 2x, which is the derivative of sine 2x, times the derivative of u, which is 2x in this case. So the derivative of 2x is 2. So that's the final answer for the first part. And same here, cosine, we can replace this expression by u, and then derivative of y would be derivative of cosine, which is negative sine of this expression, times the derivative of u, which is in this case it's x minus 1. So negative sine x minus 1. The derivative of u to the power 3x. In this case, we can treat this 3x as a u. So derivative of this expression is this very same function, e to the power 3x times the derivative of u, which is in this case 3x. So that's how we can find the derivative by using the derivative of the natural logarithmic function. So natural logarithmic function means ln, which is ln, let's say x, which is actually log base e x. That's called natural logarithmic function. So the derivative of ln of x is 1 over x, and derivative of ln of u, where u is the function of x, is 1 over u times du over dx. So example, the derivative of ln of 2x, in this case u is 2x, so it's supposed to be u prime, which is derivative of 2x over u. Just copy this 2x on the bottom and then find the derivative of this inner function on the top. That's all. So you have ln, or whatever logarithmic function you have, and there is something inside the parenthesis. Then derivative of this whole expression is 1 over that function, whatever comes inside this parenthesis, times the derivative of the function inside the parenthesis. That's all. So you can apply this rule here. This is your function, which is x squared plus 1. So using this formula, it would be 1 over f of x. Here we have used notation u, but you can also use f of x times the derivative of f of x. So what is f of x? It's x squared plus 1. So that's why x squared plus 1 goes on the bottom. And derivative of x squared plus 1 is 2x. So that's why 2x is on the top. So sometime you might have absolute value after ln. In this case, that's the derivative of natural logarithmic function. Basis other than e. Let's say you have exponential function a to the power x. Then there is a way to find, there is a way to change that base into exponential e using this this formula. So we already know what is the derivative of e to the power u. So remember, what is the derivative of e to the power u? Using the chain rule, it's e to the power u times du over dx. So in this case, u is this whole expression. So e to the power u, which is ln a x, times the derivative of this with respect to x is, this ln of a is a constant. So the derivative of x is 1. So you just have to multiply this by a. So eventually, what is this? This is actually a to the power x times ln of a. So whenever you have something else other than e as a base, then derivative of that type of exponential function is copy that function, times it by ln of that base. That's all. Example, and you can apply the very same thing for any base, log base a. Yeah, that's the change of base formula, and you can find the derivative both sides. I'm going to give you example. Look at here. Yeah, that's the formula. A to the power x, the derivative of this type of exponential function is ln a times a to the power x. Au, the very same thing, ln a times a to the power u times du over dx. If you have something else other than x only here, you always have to find the derivative of that as a du over dx. What is the derivative of log base ax? It's a 1 over ln of a times x. What is the derivative of log base au? It's a 1 over ln of a, this time u times du over dx. What is u? you supposed to, the problem supposed to give you the value of u. Example, let's say y equal to the power x. According to our formula, the derivative of 2 to the power x is ln base 2 times the function itself. Okay, so let's summarize whatever we have learned up to this point about the differentiation rules. So we started with the derivative, its introduction, and then we talk about constant rule. It's in the previous section, not in this section. Okay, constant rule, power rule, constant multiple rule, sum rule, difference rule, product rule, quotient rule, and then eventually in this section we discuss about the chain rule. Using the chain rule, we discover the general power rule, and we also discuss about derivative for the trigonometric function and the derivative for the exponential function with the different base. So these are the formula. This 1, 2, 3, 4 different slides. You have to write down them again and again, and you have to know these tools to go further. Okay,